Hello Spider Peeps. Well, today I'm going to do some experiments with one of these lithium PP3 batteries which I got off AliExpress, and I took apart in one of my previous videos. In fact, I've still got one of those batteries sitting here working perfectly in my multimeter. Now, someone commented on that video and said 400 milliamp hours at best. Where's the discharge graph? Well, I think that's what they said. I mean, it was in Russian. So obviously, as someone with absolutely no formal qualifications in Russian battery criticism, I had no choice but to take that completely personally. And it got me thinking, well, surely I can use a pi pico to monitor the voltage coming out of a battery over time. You can use a resistor-divider to do that, I think. But the more I thought about it, the more I realised that storing the data, retrieving the data, making it presentable, writing it to an SD card, and generally faffing about with picos was, well, a bit of a faff. Then I remembered something really useful. Home Assistant logs power usage over time, and it also does all the graphing for me. Now, if you've got an ESP device, you can make your own sensors as well. This little ESP clone, I think it's like a WeMust D1 mini clone. I played about with the WeMust D1s a while ago on the channel, but I've not for a while. So today I'm going to try and answer two questions for myself. How do I get one of these things talking to Home Assistant? And how do we wire one of these PP3 batteries to it without sending 9 volts directly into a pin that very much does not want to receive 9 volts? Because that would be less science experiment and more teeny blue smoke ceremony, and I don't want another one of them today. So this is the board I'm using. It's a WeMust D1 mini clone based on an ESP8266 this time. Now, the useful thing about this little chap is that it's got, as it says there, clearly on the tin, Wi-Fi built in. And because of that, Home Assistant can talk to it through ESPHome. And it's also got an analog pin. I need to go, whoa, to find that. So it's got an analog pin there named A0, and that's the key to it. But there's one little catch. The WeMust D1 doesn't want anything like 9 volts down its poor little analog pin. So many D1 boards inside have got a built-in resistor divider so that the board's A0 pin, analog 0 pin, can accept something closer to 2.3 volts. But 9 volts, that's right out. So we need to scale that voltage down, and for that we need a resistor to do that. So the wiring on this is pleasingly simple. In fact, it's so simple I'm going to have a go at drawing it again. Guess the channel. I made a right mess of doing a wiring diagram last time. I'm a 555 timer. So is this going to be any better? Well, you're the judge of that, Spider Peeps. Let's put that next to it so I won't forget what I'm doing. This is a little box like this, and we have the USB in, so that's 5 volts in, and on this occasion we'll just be sending 5 volts on with USB. Okay, so that's the easy bit. And then the important things here are this has got one pin about there that's called A0, and there's another pin all the way over here next to the 5 volts, which is called ground. So they're the two key pins for me, or the two pins for me. And then over here we're going to have our little battery. So, oh, which is which on this? I can never remember. So yeah, so this big one here is minus and the little one is plus. Okay, so there's my PP3. So we take the positive terminal of the PP3 battery and we put that through a resistor, old school resistor here, and that needs to go through an 820k resistor. And then all that does then is go back to the A0 pin. That's pretty simple. But the totally important thing, and I can't stress that, how totally important it is, the negative terminal of the battery goes back pretty obviously. I mean it's obvious. I mean, there's no way you'd forget that, is there? The negative of the battery goes back to the ground. Okay, so even though this is going to get 5 volts in here, we've got to have a circuit here, so it measures it through there. So what this is doing, I think, as far as I can understand it, if I put a multimeter against this, I'm going to get 9 volts or whatever the battery's reading at the moment. But if I put a voltage against the ground and the A0, that's going through the battery but also going through the resistor. So I'm going to get a different voltage, which is a lower voltage, which then allows me to measure the voltage on that A0 pin. That's what I think's happening. Because the 9-volt battery would just suck all the power out of the WeMOS, we power in this bit that's going to do the login by the 5 volts USB, just a plug-in USB power supply. So that's how we've got to do this. Simples. So my resistor to give me the 820K is grey, red, black, orange and brown. So the resistor limits that current that's being drawn from the battery to a teeny amount. So this measuring circuit barely takes anything from the battery. We're talking microamps for that. So if the battery gets ruined during the test, it's not because the WeMOS is drinking it dry through the measuring circuit. It will be whatever load we put on the battery that's doing the damage as nature intended. So we need to put something else on the battery. And I think to just start with this, I'm going to take something else down here, and between this what we need to do is put a light emitting diode, which is something like this, and I've probably done it the wrong way around. So diode there, and it goes to there, and that puts off the and I need another resistor there as well. All right, so if you go to settings and go to apps, and then we might need to install an app. The button's just off the screen there. The app is called ESPHome Device Builder. So let's open that. So once that's running and it's started, we click on Open Web UI. Welcome to ESPHome. It looks like you don't have any devices. So let's say a new device. This device needs to be connected to a computer using a USB cable. Once added, ESPHome will interact with the device wirelessly. Okay, continue. So let's just say new device setup. So I'm going to call this PP3 battery monitor. Okay, so once I've added my credentials in, then I want to find D1 Mini here, or I can probably get away with ESP8266, and that's installed the configuration bit. So let's click on install and plug it into the computer. All right, so this should be similar to what we've done before. So I'm just plugging that in to my Mac. So plug it into this computer. So your browser supports it, so preparing download. Okay, now this is actually running on my Home Assistant Green, so I'm going to leave this. It's going to take a while because it's not really powerful enough my little Raspberry Pi to do a full build of this. So I'll wait for a while and that will install. So I'll fast forward this bit, or I might even click my fingers like this. Okay, so I had to do it a slightly different way. That's all my code download. So now I need to go to ESPHome, and then I click on connect and I select my cable, which is already plugged in. Then install downloaded project. That's what I want to do. I need to choose OK and click install. So hopefully that should put that device on here and put this device on my network. Okay, that's done. So ESPHome built the firmware, and I did this the first time I installed it. I had to plug in the USB, but after that, if everything's gone well and this is connected to the network, I can send future updates to it wirelessly, which is nice because plugging things in is frankly medieval. Let's go back to Home Assistant, and we should have that on here. What it does is it looks at the pin A0, and every 300 seconds it's going to send a reading back, and it's got this thing called multiply 11.4. Maybe we'll come back to that. If I do install now, hopefully I should be able to connect to this and it should just install it now a lot quicker than it did previously. So if you've got a Wi-Fi access point where it sends you a notification when the new device connects to it, you've probably got one now because you've now got an ESPHome device plugged in. Cool. Let's wait for this to download. Okay, so that's compiled and it's uploading now. Then it should reset itself. That's connected. You can see the purple. That's information that's coming back over the air onto that now. So let's try and use a breadboard, like I said. So I've got one here. Let's plug it in. Okay, so here's my breadboard. I've set it up a little bit in advance. Here's my PP3 connector. I've got a DuPont connector on there with some heat shrink and some hot glue squirted into it, and that should fit perfectly into the power rails of the board. Okay, so from the positive of the battery, I've got this 820K resistor that goes into the A0. Then over here I've got the ground rail going to the ground rail this side, and I've taken that over here to give the ground rail to connect it to the other side. Whoops, that's the wrong one. To connect it to the ground rail of the PP3 battery. So that's tied the ground of the battery to the ground of the Wi-Fi connector. That's cool. And I've also put a little LED in, as I said. That's the load. I think I'm going to need a bigger load after the time. So if you see what I've done there with the LED, that's just across the battery. So it goes from the negative to a suitably sized resistor, orange, for the LED, and then the LED goes to the positive there. So that's how that works. So that should all be set up now. So let's just plug a battery in. And amazingly, when I plug that battery in, the blue light lights up. Let's go to devices and services. We should have a ESPHome there, and then we've got this PP3 battery monitor. So let's click on that. So we've got battery voltage coming off that 0.14. That's not good. Okay, so this should be at least 9 volts, shouldn't it? So let's just go into here a little bit. So across the battery, we've got 9 volts, 9.23. So this is coming from the buck converter inside there. If you remember, there's a lithium cell and there's a boost converter in there to take the lithium up to 9 volts, but we're not getting the right voltage here. Okay, so something's wrong. So what number have I got on the sensor? So if I do that ground there, well, in fact, I can take it from there to that A0. So I'm not getting ground to A0. I'm not getting any voltage back from that. That's not right. So maybe that's why I'm getting a false reading. What are my options here? Well, that resistor's the wrong value. I don't think it is. I worked that out. I've wired something incorrectly, or the WeMOS has got some strange sort of analog circuit in it that we don't know, or the breadboard's mucked up. So the breadboard, I wonder, let's put that on. So I had this before. I've not used a breadboard for ages, but I had this thing where, so if I'm just testing continuity, so I've got continuity there, and I've got a feeling these rails don't continue. So how can I test that? Well, if I plug it there and there, I'll get a value. What if I plug it there and there? Oh, no. All right, so this bit here I've not connected properly. So let's bring that. That's still got to be minus, hasn't it? So let's bring this forward a little bit. So I'm using this set of power rails here instead. So it's still to minus, isn't it? Yeah, I'm tying ground to it. All right, so what's my voltage? Now remember to set that back so we don't get some more terrible blue smoke. So that's the ground pin. What's the voltage from the ground pin to the battery now? Yay, 2.3 volts. Wrong way around. So hopefully now, the next time that sensor fires, I've got that battery reading right. So the problem was that rail was floating, so it wasn't actually connected. And the most important thing about this was that you have to tie the WeMOS ground into the battery ground for it to correctly measure the voltage, for the voltage divider to work. So yeah, so the WeMOS was reading it correctly. The setup was working, but yeah, right. Where have we got on the computer yet? So no, not yet. So let's just wait for a little bit. So we should be getting around 9 volts. And if we haven't got exactly 9 volts now, what we've got to do is measure the two voltages and do a little sum, and then we can get the multiplier to work properly. So we'll wait for when it next pings, and then we'll take a record of both of the voltages and check it's all right. Okay, so there we go. PP3 battery voltage equals 9.26. So is this about 9.26? Well, it's 9.03. So there's something a little bit wrong on that. So I've just got to alter that. What's the voltage that's coming in across this again? So that's 2.04. So the initial multiplier was 11.4. Home Assistant says that's 9.26. The multimeter says it's 9.03. The new multiplier is the old multiplier times the actual voltage plus the displayed voltage. Old multiplier, which was 11.4, times by the actual voltage, which is 9.03, divided by the displayed voltage, which was 9.26. So that gives me 1111. I'm going to update this, won't take long. So if I go back to ESP device builder, open web UI, edit this, change that to 11.1, that should do it. So hit save and hit install, and that should work. I've left this on for a little bit. The voltage now that we're getting from the battery and that it's being logged on Home Assistant should be close to the actual voltage that the battery's going. Is it lab grade accurate? No. Is it good enough to plot the discharge curve of a PP3 battery over time? Absolutely. Now I know how to do it, and that's what we need. So over time I can see where that is draining this battery. But of course I'd have to work out the power that this was actually taking from it to see how long this would take. I mean, it might take months, who knows, but it doesn't matter. As long as this is plugged in here, Home Assistant will log it for me, and that'll be good. It's just acting like a normal sensor. So I can open the entity, I can view the history, I can add it to a dashboard, I can plot it over time. That means I don't have to write a login system, I don't have to store values on an SD card, I don't have to plug a Pico back into the computer, scrape a CSV file out of it. You know, Home Assistant just quietly records the value every 5 minutes, which is exactly the kind of laziness I like to pretend is efficiency. So it's going to be interesting to see what this battery does actually do over time. So now we've got the ability to log what this lithium battery does over time. It's behaving like a PP3, but we don't know what it's going to do. Does it hold its voltage at 9 volt nicely and then suddenly fall off a cliff as soon as the internal battery is depleted? Or does it sag gradually like a normal battery, maybe like one of these would do? Does it live up to the claimed capacity? So that's the setup. A WeMOS D1 mini clone, ESPHome, Home Assistant, one 820k resistor and a little load, and a PP3 battery being monitored every 5 minutes. The first version of it that I did went wrong because I'd managed to ground it to absolutely nowhere. The second version worked, but it needed calibration as well. And now we've got a live Home Assistant voltage sensor ready to graph the battery discharge over time. Yeah. So am I going to be able to do that? Am I going to show you the graph? Well, maybe that's for another time. Thanks for the comment. This was a really interesting project for me to do. Thanks for watching, Spider Peeps. Hope you enjoyed this video. Bye. So this is now a standard power supply. So that's not plugged into the computer, so I can just leave that in the cave running like that. And it would be interesting actually to see the difference between that battery and a standard PP3 battery. So this has been used a little bit, but not a lot. Is that going to work? How's that going to hold its charge? Nobody knows.